Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 26 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2311. Longest binary subsequence less than or equal to k. So let's read the problem statement first. You are given a binary string s and a positive integer k. We have to return the length of the longest subsequence of s that makes up a binary number less than or equal to k. Okay. Note, the subsequence can contain leading zeros. The empty string is considered to be equal to 0, and a subsequence is a string that can be derived from another string by deleting some or no characters without changing the order of the remaining characters. Okay, so problem statement is very easy. Let's understand the same thing with an example. Okay, so see this example. This is string given to us. K is 5. Okay, so if I write this k in binary form, so here I can write it like this 101, right? So this bit value is nothing but 1, this bit value is nothing but 2, this bit value is nothing but 4. Okay, and the total value of this one is nothing but 5, right, in decimal form. All right, and if I represent, I'm representing it like this, right, in binary form 101. Okay, so that simply means that this is nothing but 2 power 0, 2 power 1 and 2 power 2. Okay, so this 2 is nothing but my base. Okay, and here I'm doing the power. Okay, first 0, then 1, and here 2. Okay, so this is how we represent the number in binary form, right, a decimal number in binary form. Okay, so here we have to, what we need to do, we have to find the longest subsequence, right? So here if you see, this is the max number of bits that I can use. Okay, this is the max number of bits we can include without exceeding k. Okay, so if I use any other bit, okay, and if I place here value like 1, then definitely I will get value bigger than this k. Okay, so I am not going to use that. Okay, so until here only uh, I have to find out. Okay, until only here I have to check if I can place 1 here or no. Okay, until here only. And here in these spaces we can simply fill 0. Okay, because 0 is not going to create any impact. Okay, but only in these places only I need to check whether I can place 1 or not. Okay, right? So here I can say for this 5 max bits is nothing but 3. Okay, max bits is nothing but 3. Okay, max bits 3 means the max number of bits we can include without exceeding k. Okay, so 3, at least 3 we need, right? Okay, because here if I just use these two, then also I will not get 5. Okay, but if I use until here, I can get max number up to 7, right? Okay, this 111, this is nothing but 1 2 4, this is nothing but 7. Okay, I can get 7 until here, but with this same number of bits I can also get 5. Okay, but if I don't use this also, okay, then I will never get 5. Okay, so until here this is the max number of bits that we can include. Okay, and here I can simply add 0 0 0 because these zeros are not going to create any impact, right? And we need longest subsequence, that is why I can add zeros here. Okay, so now how we are going to solve this problem? So k is 5 and we know that 101, so max bit is 3. Okay, 4 5. Okay, so now here I am going to iterate from the opposite direction. Okay, from this direction. Okay, so first here it is 0, I can add 0, no issues, I can add 0. Okay, next time here it is 1. Okay, and here it is 1 and we can add this one, right? We can add this one. Okay, so here why we can add this one? So here if you see, this is nothing but second. Okay, this is first position, let's say this is second position, so this is a second position only. Okay, we can include up to 3, right? So this is a second position only, and here if I add 1, then the value that I'm going to get is nothing but 2 only. Okay, and this 2 value, okay, is less than my 5. Okay, less than equal to my 5. Okay, so this is good, right? So that makes up the binary number less than or equal to. Okay, so this value is less than or equal to my 5. Okay, so I can include this one. Next time a 0 is here. Okay, so here a 0 we can include. Okay, and next time here, see, here it is 1. Okay, so I can't add 1. Okay, if I add 1, so definitely this value is going to be out of this 5. Okay, so next time I can simply ignore all the ones. Okay, I'm ignoring this, I'm going to add this 0, I'm going to add this 0, and this is 1, I'm going to ignore this. Okay, so what is the length you are going to get for this one is nothing but 5. Okay, so this is your output. The longest subsequence of s that makes up a binary number less than or equal to 5 is 00010, as this is a number is equal to 2 in decimal, right? So that is why output is 5. Okay, so this is the same thing that we need to do here. Okay, example number 2, k is 1. Okay, so how I'm going to represent 1 in binary form? It is nothing but 1 only, right? That is nothing but 2 power 0. Okay, okay, right? So only 1, right? So now here this is the first. Okay, we have to start from opposite. Okay, so I can place this one, so this value is equal to less than equal to k, right? So equal to k, right? The next time this is 0, right? So this is second position, but only until 1 I need to check. Okay, after that just add 0 here, delete this, add this 0, delete this, add two other zeros. Okay, so what is the length? 1 2 3 4 5 6. That's it. This is my output. Okay, and these are the constants. S dot length from 1 to 1000, s of I is either 0 or 1. Okay, and k value is from 1 to 10 to the power 9. Okay, so now let's discuss how we are going to calculate this max number of bits. Okay, so first let's understand a little bit of mathematics. Okay, so what is a logarithm? A logarithm answers the question how many times I must multiply a number the base to get another number. Okay, so log 2. Okay, how many times I multiply this base to get another number 8. Okay, so output is 3, right? So 2 into 2 into 2, output is 2 into 2 4, 4 into 2 8. Okay, so 3 times, right? So logarithm gives the answer to this question, how many times must I multiply a number the base to get another number. Okay, so this is normal mathematics, right? In Java we can't simply write it like this. Okay, so in Java what we need to do, we have to get write it like this. Okay, to get the output log 8 here, and here we have to write log 2. Okay, this is the way to write it in Java to get the same output. Okay, so why do we use it in coding problems like our today's problem? So in your case, you want to know how many binary digits bits are needed to represent a number k. Okay, so that's really the same as asking what is the highest power of 2 that fits into k. Okay, so this is exactly but a base 2 logarithm tells you log 2 k how many bits are needed to represent k in binary form. Okay, so here I can represent these bits in this form, 2 power 0, 2 power 1, 2 power 2. Okay, so until here 2 power 2, so I can make up to 5, and I can also make up to 7. But if I include this 2 power 3, so it is going directly going to make a jump to 8. Okay, so that means I can't use this. Okay, until here only, right? Okay, so in your problem you need to know how many powers of 2 bits are needed to reach or stay within k. Okay, so that's why you use log 2k and compute it in Java as math.log k and math.log 2. Okay, so in Java we have to calculate it like this. Okay, right? Okay, so now here let's understand this with a few examples. So let's suppose your k value is equal to 5. Okay, so that is nothing but our example number 1, right? So here we need 3 bits to represent 5, right? We know 101. Okay, so this is nothing but 2 power 2, this is nothing but 2 power 1, and this is nothing but 2 power 0. Okay, so multiply 2 power 2 into 1, 2 power 2, 0 into 2 power 1, 0, 1 into 2 power 0, or 1 only. So 4 plus 0 plus 1, 5. Okay, so in Java how we calculate this? So math.log 5 divided by math.log 2. So it is going to give you value something like this, 2.3. Okay, but we need 3, right? So int of this is nothing but 2 only. So what we are going to do, we are going just simply going to add plus 1 to it to get the correct max bits 3. Okay, so we have to add plus 1 every time. Okay, so here if you see k is equal to 16, so how you represent 16 in a binary form? Okay, so 1 2 4 8, and this bit value is 16. Okay, 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Okay, so k you represent it like this. Okay, so if you see manually how many bits? 5. Okay, so if math.log 16 if you do, you get this. Math.log 2 you are going to get this. Okay, so if you divide this, so you are going to get something like this, 4.01. so you can say approx 4. Okay, so which makes sense because log 2 16. Okay, if you do normal mathematics, then log 2 16. Okay, so we can write it like this, log 2 2 power 4, and you know that 4 comes out, and here log 2 base 2, and here 2, this is nothing but 1. Okay, so this value is also 4. Okay, so here it is making sense, right? in Java we are getting 4 like this, and if you know do normal math, then also you are going to get 4. Okay, so here we have to add +1, okay, because 5 bits are there, so you would consider 5 bits when k is equal to 16. Okay, when k is equal to 15, so binary of 15 is like this, so we need 4 bits. Okay, so if you divide this, you are going to get something like this. You have to add 1, so max bits 4. Okay, so k is equal to 1, binary of 1 is 1, so math.log, if you apply this formula, you're going to get 0, but we need at least 1 bit right here, a 1, right? So you are going to get max bit 1. Okay, so this is the formula that I'm going to use for getting the max number of bits we can include without exceeding k. Okay, so math.log k divided by math.log 2 int and add 1 to it. Okay, so this is a discussion for just for this line. Okay, so I hope that you guys are clear with this mathematics, why we are using this line. Okay, so and everything else is very easy, right? So we have to just make sure that only until here we can include, we have to check ones or 0, and after that we have to just simply add zeros, because these zeros are not going to make any sense. Okay, but we can get the max or longest subsequence length, right? So let's write the code. Very simple, nothing complex. So here what you need to do, let me just maximize the screen. All right, code is also going to be very small. Okay, nothing complex. So int value, okay, this set it to 0, so I can say that the value of the binary number we are building. Okay, and then here int count, and I'm going to set it to 0, and this is nothing but the number of characters included in the subsequence. Okay, right now it is 0. Then max number of bits we can include without exceeding k. Okay, so for that we have to just write the formula that we already know. Int max bits is equal to, and here we have to write int, and here we have to write math dot log value k. Okay, here plus m capital math dot log k, right? And here we have to just divide it with math dot log, and here 2, right? And this is done, and in this we have to just add 1. All right, so now just calculate the length of the string. Okay, s dot length, done. Okay, this is string, right? And then you have to start from the right least significant bit. Okay, so here I'm just going to run loop. Okay, int I is equal to 0, I is less than n. Okay, I plus plus. Okay, so here we have to start from the right. Okay, so what I'm going to do here, I'm going to write the character ch as s dot char at, okay, last position we need. Okay, so last index is nothing but n minus 1. Okay, and here from this, if I subtract just I, so I will get last index only, right? For very first time when my I is 0, so last index. When my I is 1, then second last. Okay, so this character is going to give me that. Okay, so if my character, I told you now, if it is equal to 0, then in that case you can simply just increment the count. Okay, no issues with zeros. Okay, we love these zeros, right? Now in the else part, what you need to do, you have to only include ones if we are within the safe bit range. Okay, safe bit range. Okay, so if max number of bits 3, so if we are within that safe bit range, only then we can we can add. And also we need to make sure that adding this bit won't exceed the k value, right? So here if, okay, if I is less than max bits, okay, max bits, so I is starting from 0, so less than max bits, so less than 3 means 0 1 2. Okay, so that's why just less than max bits. Okay, I value, and okay, so value whatever the existing value, so existing value is 0 only right now in the start. So if I add 1, okay, and here I will just make sure that in at which position I'm going to add 1. Okay, so 1 left fit with I. Okay, so if I am adding, okay, I have 1. Okay, if I am adding I as 1 in, let's suppose 1 position, so I have to left shift this 1 with a 1. Okay, so initially my 1 in binary format is like this, so if I left shift with 1, so I will get 0 0 1 0, so I will get nothing but 2 value. Okay, so that's why we are doing. Okay, so this is a value. Okay, so if this value, total value whatever I'm going to get here, if it is less than equal to k, then we are fine. Okay, so here what we need to do in that case, just update the new value as value is equal to value plus equal to here 1 left shift with I. Okay, right? and here you have to just simply increment the count plus plus, that's it, right? And in the end you have to simply return count. Okay, return count, right? Just change it to int. Okay, so now let's run the code and see if there are any code issues. We'll try to fix that. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. We'll see you guys in the next video. Thank you. Bye bye.